Hi everyone. I got a request for a little bit more help with solving trig equations, so I'm going to do one of these messy ones that have more than one trig function in it. So I would say that that's exactly what makes these tricky, is that there's a secant, a tangent, and a cotangent in this one. This is number 8 from day 3, by the way. So my first step would be to see if I can change that. You don't always have to, but especially when there's more than one trig function, it's not a bad thing to try. So I'm going to rewrite, and then cotangent cosine x over sine x. And then I'd like to clear all the denominators, I think, is what I would tackle next. So the common denominator here is going to be sine times cosine. I didn't really leave myself room to write it over here, but same thing. And what happens on the left side is that the cosine cancels and you're left with sine. And on the right side, we're going to have to distribute. So the first one, we get to cancel the cosine out, and we're left with sine squared. In the second one, we get to cancel the sine out, and we're left with cosine squared. And that's actually fantastic because sine squared x plus cosine squared x is equal to 1. So I actually just end up with sine x equals 1. And if I go to my unit circle, as soon as you isolate that trig function, you're ready for your unit circle. I'm talking about all the points that are right at the top of the circle. So pi over 2 is a great one, and then every 2 pi after that. So for all solutions, oh, and I didn't copy over direction, so I don't know if this is all solutions or just between 0 and 2 pi. If it's between 0 and 2 pi, you've got it. If it's all solutions, I would say x equals pi over 2 plus 2 pi k, where k is an integer. Okay. So that's that one. I know they probably don't all work out so nicely as to just turn into sine x equals 1, but this beginning step where you rewrite everything in terms of sine and cosine is one that I highly recommend. Let me know if you want to see any others.